Okay, hi there, and good morning, viewers. Um, Yet another DCD talks with myself, George Rocket, the CEO of DCD. I hope you're finding them interesting. We try and get a little bit deeper into conversations. Today, I'm joined by Paul Unbehagen. He is CTO of North American Enterprise at Nokia. Have I said that correctly, Paul?
Yep, and global web scale.
Okay, perfect. I'm thinking more of the Nokia or the Nokia. Is there a way? What's the
It really
preferred
depends what
way?
continent you're on. To be honest, I'm sure there's a proper way when you're in Finland, but internally and externally with customers, it's just whatever continent I'm on, whatever feels comfortable.
I like trying to say things in the regional intonation, and we have a game at work sometimes. So we try and put our best Finnish accents on, or for Ericsson, we try and get a
Yeah, we
little
can't do that here in the States as well.
bit. So it's really cool having you here today because Nokia is not a traditional company that we would have from the DCD centric perspective. A lot of the time we're talking about the downstream effects of whatever you're doing, but in this world that's becoming more and more the edge is the discussion everywhere. Your name crops up more and more because you're building that edge, that 5G edge, the edge clouds, and all of the above. But I want to get an understanding of where you sit, because in our prep call, you were saying, web scale, enterprise, we work with very big data center operators. So can I get just a little education first about what your role is, and also your worldview of the data center as it stands today as a business?
Sure. Okay, so my role is I help both the engineering side, the marketing side, the sales side. I sit between all of them, trying to understand the strategy and where we're going, and what's even happening in the data center world. And specifically, given my background as a standards member in both the IETF and IEEE, and being a protocol designer, networking protocol designer, that's the areas obviously I focus in. So what can we do to help make networking more cloud-like, essentially? And so how can we participate in cloud environments and even help different accounts which move at different speeds and have different requirements and different needs and different wants, all three different things, participate as we've evolved into this cloud kind of journey. And so if you think about like a web scale vendor, they have far outstripped everybody in their understanding of how to actually manage clouds. They don't need a lot of help in the software, they don't need that. But we do participate in a lot of conversations about, say, undersea cables, because we have a fleet of ships that actually lay those cables. We participate in defining new standards for the optical interfaces, like ZR optics. So a lot of that conversations, or even how do we participate into an edge cloud environment where when 5G is no longer these massive boxes on the side of the road that run the space stations, but actually have now been converted into containers themselves. So the entire infrastructure that runs the containers. So what's the strategy and how to manage that? Then also, how do we take that and run that in private wireless? What are you going to do once you have wireless deployed, both in the public sense and the private sense, and you have all these IoT devices now with little radios in it, and you can get any telemetry you want at any moment? How should you store that data? Where should you get access to it, and what kind of speeds you need? So it can go in a lot of directions really fast. As far as the current market of the data center, I'm going to answer that in a slightly different way. So not necessarily the Nokia way or the data center way, but kind of a combination of both. Because we see and participate with customers and on standards boards, and we have Bell Labs who participates in creating this crazy technology like AI-driven drones using cloud technology on the edge, right? We see a lot of the environment that a lot of other vendors don't, because we're seeing the actual edge devices. We produce those devices. We don't make cell phones anymore, but we still help actually with what the design of the SIM cards are going to be in a lot of these edge devices, all the way to the radios, to the networking devices. Most of the conversation we're having right now, I guarantee you, is not only happening over our fiber, our optical gear, even our routers and the broadband coming to us, and the wireless infrastructure. We provide the routers, the switches, and all that kind of stuff to every major vendor around the world. So we're seeing a lot of these moving parts at the same time. So if the infrastructure of 5G is cloud, the edge is edge cloud and is providing data centers. So we end up having this infrastructure that's providing all of it at the same time at multiple layers, and it's all moving at the same time. So pretty much data center has become a homogenous term where it's everywhere. It's not just some central location somewhere out there in some amorphous cloud. It's everywhere all around you at the same time.
So in a strange way, the data center market's talking about the edge and the proliferation of edge, and these new edges and coming up with new words for it, like nano edge and micro edge. And you from the edge are looking back going, we just need more data centers everywhere. It's data center.
Yeah, it's just, stop thinking of it as more data centers and different data centers. It's a data center. It's everywhere. It's cloud. Okay. It's just there. Okay. And sometimes that might be half a rack. Sometimes that might be 5, servers, or 5 racks, or it might be 5,000. It all depends on what you're doing in each location that drives the requirement for it. And by the way, there's still a lot of those 5 rack to 50 rack data centers that are going to exist inside enterprise forever because of regulatory issues, right? So how do you make those different environments that are all data center work together?
Yeah. So I want to push into 5G first, but I just want to go a little bit deeper on you. Where did you get into data center? I know you're at Big Switch before this. What's your personal journey? From where did you come from? From IT? Are you an engineer? When did you walk into your first data center? I always ask people that.
If we go way back, I actually started in the military. I was a paratrooper and grew up out of the IT concept of what does it mean to digitize an entire military. Right? Long before we had this kind of environment where everything is, I was part of those people who said, okay, we're going to remove all paper from the military. And so I worked in that project in part of what's called the U.S. Army SOCOM kind of projects for the 2nd Airborne. That started and paid for 2 degrees, and I ended up working at MCI WorldCom and running one of the largest internet connected environments there with a great group of people, which led to a career in vendors and back to startups and back again to big vendors and back to startups. And that was one part of the professional career. At the same time, another part of the professional career was working in standards, because we need to do new things. We need to standardize it so everybody can work together, right? So I was on the 802.1 group, actually a voting member for nearly 18 years. I co-authored several standards there. I helped actually at the time when I worked at one vendor, I was one of the voting members for the company that did the passing vote for 802.11ax, so that it would actually go past and become an industry standard. In the ITF, I published and was part of several RFCs, about 47 patents along the way. And for me, I don't see that there's a difference between, say, wireless and wired. They're all access technologies. Just the interface itself is different, right? So if it's RF or electrons or photons, you're just sharing information. Right? How you share the information, why you're sharing the information, what it's used for the end user is what's important to me. That's probably because I came from a large background. We were dealing with, we need to get gear out fast. We needed to make sure it was stable, reliable, and then it didn't fail ever. So I don't really focus so much on it. It's got to be wireless. It's got to be wired. It's got to be basically a full network infrastructure that provides a better service to the end user.
That's a really interesting perspective. So you're at the other end of the pipe looking down, calling the same pipe a different name or looking at it in a different way. And from a study perspective, electronics engineering or what, what's the...
computer science software. Okay. So
Okay.
So like a lot of my patents are in routing protocols like BGP, ISIS, MPLS, Ethernet, things like that. Right.
Fascinating. That you've got stuff pinging in.
Yeah, I just turned it off. It's the connected world of working from home now.
So in all of that trajectory, right? Technology, access to technology by the masses, by everybody has increased. The density of their access has increased. Their bandwidth has increased. Is there a stage which you found the most interesting in the past? Big leaps or paradigm shifts that you said, wow, that was it? Or is it still to come, or are we in it? How do you typify that journey from an excitement perspective?
I think every decade provides its own unique excitement. And, if you kind of look back, in the next 25 days, or even just the Faraday days where they've discovered a Faraday cage, each one has these amazing discoveries that come forward, and we all stand on the shoulders of giants. And I don't think there's enough appreciation among young engineers about the fact that everything they're inventing, great, but you're standing on some amazing giant shoulders to do this, right? So have the appreciation and gratitude for what you have as a foundation to move that forward. Everything from Ethernet used to be coax to now we're running it over fiber, and we're sending it over microwave, and we're actually sending it up to the stars and under the ocean now. So that's great. Also, one of the observations I would say anecdotally that I like to point out is that it seems like every 10 years, the world of networking specifically, but even I'm starting to notice in data centers, goes through these massive shifts. right? Something happens, let's say, Moore's law, there's something happens with supply chain, there's something that happens with a new way of thinking, a new generation hits the market as well, another generation retires out, and that was holding back thinking. And those combinations of those things coming together, it causes a completely different way of thinking about the world. We went from mainframes to PCs, we went from X25 to ATM, and ATM went to MPLS and Ethernet. At the end of the day, IP and Ethernet won flat out because of economy of scale and economy of scope, which then led to the value of being able to do servers the way we do servers today at scale and mass and the commodity. Storage now is able to do a fraction of the price, right, that we could ever do before. So then you look at the next 10 years, I think I'm pretty excited to see what happens now as we look at this juxtaposition of, we have cloud, we have AI, ML, we have potentially quantum computing coming, right? We have edge computing, and if the entire world is a data center, we have blockchains going where there's are now a new type of thinking about data. And if it's all working at the same time, what are we going to look like in 2029 compared to 2021 is going to probably be so vastly different than anything we can ever freaking imagine, that any promise or prediction is basically holding on a magic 8-ball and you're guaranteed to be wrong.
Okay, that's big. I'm going to ask you into predict, but not so precisely, but you spoke there about, standing on the shoulder of giants and iterations and changes. And, a topic that we need to cover is 5G, but maybe is it 6G, or because if it's 5, there must have been 4, 3, 2, and 1. Right?
Oh, there definitely was. Yeah.
It's got so much attention, 5G. And in a way, people argue that nothing's really happened yet. There's the arguments of whether pandemic slowed down or speeded it up. Is it so groundbreaking that it's just taking longer to come together, or what's the story behind it? I know Nokia is is mentioned in this all the time. You are a central player to this.
Yeah, so I'll give you the data guy who I actually have written software for and helped out on Linux a lot too. So I might have a different perspective than the rest of my peers here at Nokia who are on the wireless side. But I think we'd all agree on this statement, is that the change from 1G to 4G were iterations on technology and approach. The change from 4G to 5G was a complete overhaul of the infrastructure. So instead of running these massive specially designed appliances that were NEBS 3 compliant, that sat out in the middle of fields and would be fire protected, have shotgun tests on, we still do that for the particular set of software or devices sitting at the bottom of the tower, but they are no longer a 10 by 10 or 20 by 20 shed. They're now just a rack of servers. And most of the actual control of the tower and the radio is actually being done on Kubernetes containers back in a central data center, and also here locally as a combination of functions. It's all cloud-based, right there at the edge. So that overhaul took a lot of time to agree on first what is going to look like, so that everyone can interoperate with each other, so we can mix and match, the antennas, the radios with the servers, and make sure the communication, because we're no longer really thinking the concept of ENOBs, and we think of all these other things, and it's all IP underneath too. That was a big change from 3G to 4G, was that we moved to the all IP infrastructure, and that laid the groundwork to get to this now, we're a cloud-like infrastructure. If we hadn't done that 3 to 4 and 4 to 5, all right, so we wouldn't be where we are today. That being said, yes, I would say the pandemic definitely slowed down some of the deployments. If you think you're being forced to lock down inside, people are worried about, okay, can someone go outside? What's their health benefits? There's a whole bunch of regulatory and legal issues wrapped around that. There were several municipalities and cities out there who, as things started to calm down, understand how we could safely move people around, did start to deploy more. But there's also, because it's a cloud-like infrastructure, a lot of the infrastructure side of itself could be deployed on its own without the actual radios, right? Because it's all cloud. We can deploy some containers, move things around once you have the server infrastructure, and a lot of that was actually in place. Secondarily, devices. Devices are now starting to come out en masse with the ability to do 5G. So the iPhones, for example, and all modern Androids can do it now too. Right? We're seeing even IoT chips come out with the ability to do 5G, although the 5G, the reason why the IoT devices are looking at are different than what we'd say like your tablet would, because the IoT device doesn't really care about the amount of bandwidth as much, say, as your iPad streaming Netflix. What the IoT device cares about is extremely low latency in a lot of functions, because you might be getting live data telemetry that could be at risking someone's life, right? Of course, there is low latency when you're talking about gaming over 5G, so both ends get the benefit of that.
It's really interesting. The way that you explained it, the move as a total shift from 4 to 5, hadn't been explained like that to me before. By the way, I'm not an engineer nor an IT person.
Okay. No worries.
But most of the people listening know that, which is kind of like why I ask questions sometimes are a bit basic, but sometimes the questions that other people don't ask and they should ask.
That's very true.
So we've got that 5G world, which is really groundbreaking. I've heard people say that 5G is being adopted quite a lot privately, from an enterprise perspective, factories, deployments like that.
Yeah.
Is that the case? And I'm
Yeah.
assuming that companies like Nokia have to be involved in that.
Yeah. So because we make obviously everyone knows this for the wireless infrastructure that we provide, and that's all based on cloud. And we're seeing a lot of that 5G and something we call like 4.9 being deployed into like ports authorities, transportation, retail, manufacturing, a lot of environments that need broader reach than say Wi-Fi alone can do. So the combination of Wi-Fi and private wireless actually provide a huge boon to the productivity of what can wireless do for me, right? Because now you can put up both Wi-Fi in the building, and you can put up a radio that's doing 5G or 4.9, kind of function that covers an entire campus. Or say for like a school district, when in the middle of a pandemic, you can extend what was the Wi-Fi network inside the school, put up a radio tower, private wireless for the municipality, and suddenly now you're extending the school network into the homes of the students directly. So they're participating in class at their home, dining room table, the same way they would at their desk back in the classroom. And we've done this for a lot of municipalities, especially here in the States, where we funded a lot of what we call RDOF and other functions for growth in the education to help deal with students in low-income areas, for example, to help them participate so that their education didn't get affected and there wasn't this disparity in education for, based on income. So we were able to balance that out. So yeah, we're definitely proud of that. I mean, in the background too, there's a lot of work we're doing on what does that mean for the data center's functions. So we actually wrote an entire new network operating system for the top of rack switches and the core, right, in combination with Apple and a few other vendors, saying like we got to stop doing these networks and the data center switching the way we used to. It's just everything's got to change. So not only are we looking at from the edge, we're also looking at the data center that's supporting that edge, that's supporting the 5G, because to do this at scale and to do it truly, the way we need to, we had to rethink a lot of those layers.
Okay, really interesting. So that rethink. So you've taken me to the next stage here as well. In data center landia, our conversation is on one side dominated by what the edge is going to bring, and we have lots of engineers talking about how you can cool it and power it and all sorts of different things.
Yeah.
And then our other conversation is about the effect of the hyperscalers on the market in general, right? Half of all colo that's being built, the billions of dollars, hundreds of billions of dollars annually being poured in by 4 or 5 players. And everyone always, there's that question of where's their play within this? And you brought up companies like Apple. Can you talk about that as well? They have so much dominance. Are they helping define this market?
So yes. And I want to point out that on the shoulders of giants, where that history always repeats itself kind of theme that we talked about in the beginning of this conversation, their effect has been very beneficial to the market as a whole to kind of wake us up to that we need to do things better. The reason why I say it's kind of repeat a theme of history is, well, the effect of what I would say that those web scalers is just very similar to the effect of what the Verizons, the AT&Ts were. I mean, it was MCI in the day back in the 90s before it was Verizon, but those were the ones that actually invented the routing protocols that run the internet, for example, BGP, OSPF, and all that. Before this protocol called OSPF, for example, which is now the predominant routing protocol, pretty much runs every single campus you see around the world, right, that are running routers so that you sitting at your desk, if you ever go back to your desk, or sitting in a school, for example, they're running OSPF. That was a carrier protocol back in the 1990s. The early 90s, you were told as an enterprise, stay away from that, just use RIP. That's the carrier protocol. Today, that's laughed at. Like every enterprise in the world would never touch RIP. They're all using OSPF. And so that's a natural evolution. And you can see that in any world of engineering where something that becomes complicated has to work itself out in the economics in environments that can afford it. And then slowly it gets down to a commodity as economies of scale and scope increase. And then it becomes ubiquitous and everywhere, right? A great way to see that, for example, is airbags in your car. That used to be a luxury item. Now it's in every single car produced. right? So it's the same concept as we apply here. So those web scalers and their effect on the market, what they've been able to do for the cost per port of Ethernet from 10 gig all the way up to what we're going to see in 400 gig in ZR optics has been phenomenal for the entire industry. Their push into how we actually think about running a data center and to stop thinking like it's just a giant campus, right? And that's actually, I would say, like when we used to teach networking engineers in the late 90s to early 2000s how to design a data center, you could actually superimpose a picture of what was a campus design and they were exactly the same. And that did not serve the people that the network was serving, the actual application developers, the database guys, and more importantly, the end users. So the cloud guys allowed us to actually see, we need to think about this completely different how we manage this stuff. Also, we need to stop designing networks for networking people. We need to start designing networks for the actual application. And that's another effect that we saw for that these web scalers have done great benefit to how we grow. I think the next phase in which what web scalers have really done a great job is this concept of white box and using commodity chips, basically. So the white box concept is, you could talk about the economics and everything, and white box has been talked to death. For me, as a software guy coming from that background, what I like about it is means that we need to, it's just part of what we had to rethink here was we need a different network operating system. We need to stop treating these switches like there's something special. They're a CPU with a switching chip with a bunch of ports. Okay, that basically means is that they're a server with a bunch of ports. So why not just run the actual software on it as actual Linux, and then run the applications that run the switching that knows where everything is as an application like we'd run a web server, and then open up the entire kernel that's running Linux so we can run the switch the same way we run the server. And that opens up this huge environment of opportunities of toolkits now that allow us to manage the servers and the switches in exactly the same way, taking DevOps to a whole new level. Now, the current term internally we call it as NetOps, but that's why I was talking about how we had to rethink the way we actually look at the switches that run the data centers, because it's going to allow us then to use the same API software development tool sets and approach that run the server and the switches at the same time. So it really simplifies the operations environment.
So software defined and open are really the underlying enablers of all of the fabric.
Yeah. Being someone who was heavily involved in the SDN push in our years, for me, this is actually seeing the actual the delivery of the promise of what SDN was without it's like SDN must be done this way. No, SDN was a concept, like everything is software defined, but what's really important is that everything wasn't open. And now we're at a point in the industry where everything kind of like is intersecting in a perfect way, where the API concepts, a whole new set of developers graduating from university as well, who think about the world differently. They don't want to look at a CLI. They want a web doing an API call, right? That drives a different cultural view of how to look at it as well. Networking people who are no longer thinking in the same way as well, that everything has to be CLI driven. They can see how that they need to provide a better environment that's as agile to the actual server infrastructure so that everything can move, because at the end of the day, you're not measured by how fast you deploy this data center. You're measured by how well your application runs.
It's a fascinating, complex world. It's funny because software defined we're talking about for so many years, and now, as you've said, it's something that's here. It's these things are talked about and they become reality, and then they're no longer talked about. It's funny, right? They seamlessly flow in.
One of the analogies to that I like to point out is being in a big electric car vehicle guy. I've had an electric motorcycle and electric car as well. As people talk about charge anxiety. Everybody has charge anxiety. You have charge anxiety if you have a gas car. You just don't realize it because there's a gas station on every corner, right? Or a petrol station for you, but for us. But every now and then you get to a quarter tank of gas, you have a charge anxiety. Like, where am I going to get my electrons from, right? So it's a system that's so ubiquitous, you stop seeing it.
Yeah. The light switch. The light switch that is data. Hey, we've been gassing on and on and on, right? You've got a day job. Where are you? You're in Denver. Right, it's Denver and it's Monday morning.
Yes, early Monday morning.
Early Monday morning. I've had a fascinating chat today. I can tell you what, I've learned a whole heap of stuff. Hopefully, I can invite you to join one of our conferences soon, because I could just see you bringing a little bit of energy to a panel. But for today, it's been great, Paul.
Oh yeah, it's been a pleasure.